All right, in this video, we're going to work on the following problem. It says, what is the value of cotangent theta if the terminal side of the angle theta intersects the unit circle in the first quadrant at x equals 7/10? All right, so if we draw a little picture of this situation, and this problem should probably say that the angle is in standard position, meaning that its terminal side or initial side, right, is along the positive x-axis, and the terminal side or the vertex is at the origin. So they tell us that the terminal side intersects the unit circle. That's the circle centered at the origin of radius 1. So it'll intersect at, say, this point here. Let's see. At this point right here. And they tell us that the x value is 7/10 on that. And they don't tell us what the y coordinate is. So for right now, we will just put a y there. Okay, we're going to have to figure that out. But we do know the x coordinate right here. And the thing to remember about that is that in this situation where we have an angle in standard position and we know a point, the point on the terminal side of the angle where it intersects the unit circle, right? We know that the first number is the cosine. So the cosine of theta, right, from the information that they have given us would be 7/10. Okay. And then whatever the y coordinate is, that's going to be the sine, right? And at this point, we don't know what that is. Okay, so that's what we've got to work with. What we're trying to figure out, though, is the cotangent, right? And so we know that the cotangent, in terms of the cosine and sine, right, are going to be, cotangent is going to be cosine theta over sine theta. So we know the top part of this, it's 7/10, right? But we do not know the bottom part. All we know is it's y, right? Whatever that y coordinate is right here. So that's what we've got to figure out. If we figure out y, then we'll be able to figure out what the value of cotangent is. So how do we do that? Well, what we do is we'll go to the fundamental identity, right, relationship between sine and cosine, and that is that the cosine squared of an angle plus sine squared equals 1. Okay? And so that little equation will allow us to figure out what the value for sine is. So the value for cosine, we know it's 7/10, and don't forget to square that. And then sine squared, we don't know what that is, so we're just calling it y here. So we can do that, so we'll have to write a little less and keep then having to write sine over and over again. Okay, so we just need to solve this equation. And so first simplify this left side over here. So that's going to be 49 over 100. Right, when I square 7/10, it's going to be 7/10 times 7/10. So on top, I'm squaring the 7, which will be 49. On the bottom, I'm squaring the 10, which will be 100. There's nothing to simplify over on this side. It's as simple as it's going to get. So now that both sides are simplified as much as possible, then what I'm going to do is get this y squared by itself on one side. And so the first thing I'll do in order to do that is to subtract 49 hundredths from both sides. So over on the left-hand side, I'll have 49 hundredths minus 49 hundredths. That's going to be 0 plus y squared. So over on that side of things, I will just have y squared, which is what I want. I want that y squared to be by itself on one side. Over on the right-hand side, right, I need to subtract, do this subtraction, 1 minus 49 hundredths. In order to subtract two numbers or two this fractions, right, they have to have the same denominator, common denominator, right? And so these do not, right? One is written as a whole number, so I need to write that as a fraction, some number over 100, so that they both have the same denominator. And of course, right here, there's not a whole lot of work that we have to do to figure out that it would have to be 100 over 100, right? Because 100 divided by 100 is 1. So 1 minus 49 hundredths is the same as 100 hundredths minus 49 hundredths. So when you do that, right, when you subtract two fractions with a common denominator, you subtract the numerator. So 100 minus 49 is 51. And then you leave it over the same denominator. So 1 minus 49 hundredths comes out to be 51 hundredths. Okay, so I've got the y squared solved for. And so the next thing I want to do is use the square root property. Right, the square root property says that if I have a variable squared equals a positive number, then there are going to be two solutions to that that are real numbers, right? And it's going to be plus or minus the square root of that number. Okay, so that's what I've got. And for this problem, right, I have two choices. I have a positive one and a negative one. So the answer is, okay, well, which one do I use? Well, in order to do that, remember, go back up here and see where your angle is located. That point, right, they tell us it's in the first quadrant. So it's up here in the first quadrant, and up there in that quadrant, right, the y values are positive numbers, right? So the y value up here, because it's above the x-axis, right, on that point, it's going to be the positive version of that. You know, if it were down here in the fourth or third quadrants, then we would have chosen the negative solution. So here we know that the answer is, on the sign, is positive 51 over 100. We need to simplify that. You don't want to leave fractions underneath. A radical, right? And if I have the square root of a fraction, that's the same as taking the square root of the top over the square root of the bottom. In this case, both these numbers are positive, so that works fine. And we need to reduce these radicals as much as possible. And so the square root of 100 is 10, so that works out nicely. And then the 51, that can't be reduced. I think 51 is, what, like 17 times 3, which you can't reduce that out. Okay, so now we know the value for y, okay, square root 51 over 10. So now we can go back to the thing that we're really after, right, is the cotangent here. We know that that y is square root 51 over 10. So go ahead and put that in there. So I'll have 7/10 over square root 51/10. Okay. And we're going to need to reduce this, right? This is a complex fraction. That is a fraction that has fractions in the numerator and denominator, right? So we're going to have to reduce that out. Okay, so when we reduce that out, how we divide fractions, right, is we invert the bottom one. So take the reciprocal and change from division to multiplication. So we're going to have 7/10. Instead of being divided by, it's going to be times, right? And then we'll take the reciprocal of this. It was square root 51 over 10. So when we invert that, we get 10 over square root 51. All right, and now we can reduce that as much as possible. So here, these 10s will cancel each other out. Everything here is multiplication. We have a common factor between the top and the bottom, right? 10 on top, 10 on the bottom. We can cancel those out, and we're left with 7 times 1 on top and 1 times square root 51 on the bottom. So that's what we get as the answer. That answer is, since I think this is a Newton problem, Newton will accept that answer that you enter in there. And but however, in other contexts in our class, you might see this written in a different way, and that is without having the radical in the bottom part of the fraction. So you need to be able to do that and recognize, when those two numbers are the same. So if I rationalize it, in other words, remove the root from the bottom, what I would do in this particular one is to multiply top and bottom by square root 51. So I get 7 square root 51 on top. And here I have square root 51 times square root 51. That's going to be the square root of 51 squared, which just comes out to be 51. So like I said, these two answers are equivalent to one another. Newton will probably accept this. On some of the other homeworks and things that might be multiple choice, then you might have to rationalize it like this to get the answer, to be able to select the right answer there.